Hello, my name is Jesse Samitas, and together with Tom and Dev, we're here to introduce you to the new era of high fidelity simulation. This is the Gt4 Driver in the Loop simulator. I would like to introduce you to the racing world. Now, racing is extremely expensive. There's changing technical regulations that teams have to keep up with. There's track time that they had to buy. There's technologies that have to implement into the cars because other competitors are already implementing them. They have to pay the crews, they have to account for fuel costs, and they have to buy the vehicle itself. A simple breakdown of just the engine and some parts of the car, it's already upwards of $150,000 for just one vehicle. We have to keep in mind that racing teams have to build multiple vehicles so they can test different configurations, and also take into account that some of these vehicles might get wrecked during testing. Not only is racing expensive in a financial sense, but it can also be expensive in a human life sense. Racing can be, and it has been proven to be, very dangerous, especially during testing, since some of the technologies that are being tested have not been used in real life applications yet. Racing also requires a lot of training. So a question naturally arises: can we tackle any of these aspects? Can we save expenses somehow? Can we tackle one of them, or can we tackle all of them at the same time? The unsurprising answer to this question is a resounding yes. So who cares about racing, and why do they care about racing? It is not only the driver and the racing team who want to go on and win the prize. There's other sponsors, there's the car consumer who maybe wants to buy a vehicle which they've seen on TV and has been proven to have some reliability. Most importantly, however, there's the car manufacturer. Because their car reputation is on the line, having a car they're built go on and win a major racing event could potentially mean millions of dollars in marketing cost savings or as a sales boost. A good example of this is actually back in the 1960s, when Ferrari invested their entire budget in the racing division and went on to win all the major racing events, which eventually led them to the place they have today as one of the best car manufacturers, only because of their racing heritage. Now, many racing teams nowadays rely on other methods for testing. They rather optimize subsystems separately, which actually does not ensure that the system itself is optimized to work within itself. And they rather spend a lot of money into buying track time. Naturally, this carries a lot of unnecessary risk and expenses. Some teams out there have started to lean towards the use of a simulator. However, most simulators nowadays cause motion sickness. They're basically glorified video games, and they do not help the driver learn the car itself, only the track on a very basic level. Having noted some of the weaknesses of present-day simulations, what we propose right here is a new era of racing simulation, in which we harness the computing power of present-day systems in order to create a fully fledged digital twin of the actual car on the actual race day. This will be an ultra-realistic, real-time, multi-physics driver-in-the-loop simulator, which, unlike other systems, can actually explore the human-vehicle interaction which occurs during the race. The driver can get feedback from the car, and the car can get feedback from the driver. Now, the advantages of investing in such a system are not only the obvious ones. It's not just about cost reduction and minimizing the risk for the driver. There's also opportunities for the engineers to tune the vehicle to different specifications with simply the click of a button and get immediate feedback from the driver as to how the vehicle responded to those changes. For example, different suspension parameters can be tested, or reaction forces on the steering wheel. There's endless possibilities as to what can be tested, and immediate feedback can be obtained from the driver without the need to actually modify a real vehicle. There's also the opportunity for the driver to have as much simulator time, as much practice as needed, most importantly, whenever it is needed. finally, the most powerful tool of our system is the ability to optimize not only the different components of the car, but rather the entire system itself. We will optimize the human plus the vehicle and the subsystems, the vehicle and the track, and finally the driver and the track through the use of the optimal racing line, which shall be explained by Dev during our concept of operations.
Thank you, Jesse. That was a great introduction about GT4 racing industry, and I also want to personally thank you for creating this awesome ConOps slide. So previously, Jesse highlighted the need for GT4 simulator and how it reduces dependency in real-time physical testing. Now I'll be presenting you on how we plan to implement this GT4 simulator with this ConOps slide. So as you see from this slide, we have 4 different phases. Now, phase 1 is racing line determination, phase 2 is simulation training, and phase 3 is the actual physical lab test, and the phase 4 is validation and optimization. So I'll be going into the depth of phase 1, where we have engineers working behind the screen in control room, where they'll be studying the lab circuit, and they adjust the vehicle conditions and run automated simulations to come up with the best theoretical lab. Now once they have the best theoretical lab, they want to evaluate with a driver in the driver in loop simulator. So in phase 2, the driver, or probably I should call them as a racer, will be called, and they will be driving the driver in loop simulator, and the feasibility of the theoretical test will be evaluated against the simulated data. And the best part about this driver in loop simulator is that there will be a constant feedback from the engineers in the control room, where they actually give feedback to the racer if he is actually moving away from the trajectory of the racing line. So multiple simulations, multiple lab tests will be conducted, and it will be statistically evaluated to study the vehicle dynamic conditions, the racer's performance, and the feedback of each lab test will be shared to the racer after every lap. And after phase 2, the driver will be moving, the driver or the racer, I should call them racer, will be performing a physical lab test at a racetrack in a real GT4 racing car in a real circuit. And the physical data will be evaluated. Now, how do we get the physical data? We have sensors incorporated in GT4 racing car, and through the sensors we get the physical data. We have a lot of sensors incorporated in the car. Now once we have the physical data, it will be given to the engineers who will process the data, and the engineers will be working on to process the data, and that will be happening in the phase 4. The engineers will validate the physical data with the simulated data, and based on the feedback they get from the physical data, the engineers will try to optimize the racing line condition by changing the vehicle parameters and by studying the circuit again, and they do data-driven modeling from the data they get from the physical test, and somehow they try to make sure that they get the best optimal racing line by incorporating the data from the physical test and also from the simulated test. Now this iteration will be done until they get the optimal racing line. So that is all our ConOps, and after this one might wonder, what if someone has done this before? So to our best knowledge, no one has come up with a GT4 driver in loop simulator per se, but there are some competitor simulators in other racing industries. Now for example, Ford has an R&D center only for the NASCAR racing team, Mercedes and Ferrari, on the other hand, they have a driver-in-loop simulator for Formula One team, and they have some custom-made simulators in the market. But as you can see, all these simulators have some kind of a pros and some kind of a cons. So, for example, if we see Ford simulator has this motion sickness, and their simulator doesn't resemble the actual car. And if you see Mercedes, it is only for experience. Ferrari, on the other hand, has a state-of-the-art simulator, but even the state-of-the-art simulator doesn't have a high fidelity model. So it shows that there is a room for improvement for developing a simulator, and that is what we are aspiring to do. We want to create a simulator that is the best for the GT4 racing industry, and that doesn't have any cons that is listed in all these competitor simulators. Now I'll be passing my torch to Tom, who will be explaining more about the design aspects of the GT4 racing industry, GT4 racing simulator. Thank you.
Thanks, Dev. So with this concept of operations in mind, we set out to determine what the top priorities of our customer are. We implemented a rigorous quality function deployment and determined several stakeholder and customer needs that broadly fall into 4 categories: providing a return on investment in terms of lap time, keeping the driver safe, providing a sense of familiarity to the driver between the simulator and the on-track vehicle, and obtaining a competitive advantage over the competition. We then identified several key metrics to evaluate possible designs on. These include data transfer rates into and out of the simulation computing hardware, the refresh rate, frame rate, and field of view of the visual display, the simulator runtime without maintenance, i.e. the reliability of the entire system, racing line determination time, the degrees of freedom achieved by the cockpit or cabin, how long it takes to configure a new simulation with a new setup on the vehicle, and latency between driver inputs and visual and audio feedback. With that in mind, we evaluated 3 different alternatives, one basic, one advanced, and one intermediate. The basic option is a kind of good beginner option. It's definitely inexpensive, the budget option. Intermediate, it costs a little bit more, but you get a lot more with that extra money. Type 3 is most expensive, will provide the highest fidelity, but maybe an unnecessary level of fidelity. So with that in mind, we recommend moving forward with the intermediate option as the best value for the money. Now that intermediate option is represented here by a bit of a crude sketch, but basically it involves a visual display in the form of several flat screen TVs mounted together to provide a full peripheral vision for the driver, which will reduce motion sickness and enhance realism for the driver. The audio will be a 5.1 audio system, providing a great sense of being out on the track with the engine revving. The simulator cabin will be mounted on rails and tilting struts to provide a sense of acceleration, deceleration, as well as roll when the driver turns. The design concept uses custom pedals, wheels, and a gear shifter that will match the real GT4 car, providing that sense of familiarity for the driver between the simulator and the on-track vehicle. It will also include communication capability between the driver and the simulation operator or the control room. And lastly, the on-screen display will include the option to display a racing line with speed and trajectory corrections for training and practice for the driver. That's the cabin and virtual environment. It also concludes the all-important simulation computing hardware and storage room. So on the computing side, there's a high-fidelity model, which we would use Dymola and Modelica, taking advantage of large existing libraries of vehicle dynamics models that we'll use to find the optimal configuration for our vehicle. The simulation software will include a finite optimization algorithm to determine a racing line that works best unique to our particular vehicle configuration. And we'll use cloud storage to store the vast data that we collect during simulation runs and from the sensors on the on-track vehicle. In conclusion, the Gt4 simulator provides a clear advantage by reducing or even eliminating the need for dangerous track time. A driver-centric display and low latency will eliminate motion sickness and enhance realism for the driver. The use of our optimal racing line will provide advantage versus the competition by noting the best theoretical speed and direction corrections during a race. We can put any track shape or parameters into the simulation, and we can use the simulator as a training tool or comparison tool for multiple different drivers. The high fidelity and multi-physics aspect of the simulator allow the driver to learn how the actual car will behave, especially after configuration changes. And the simulator's physical feedback and modular cockpit design will provide a sense of familiarity, enabling the driver to move seamlessly and confidently from the simulator to the on-track vehicle. Thanks on behalf of myself, Dev, and Jesse. We're really happy to present this, our design for this Gt4 simulator to you today, and we hope we'll be working with you in the future.